Next problem we're going to look at, it says we have among pairs of numbers whose sum is 50, which pair has the maximum product? And what we want to know is what pair has the maximum product, but also what is that maximum product? Now, our two numbers that have a sum of 50 are x and 50 minus x, because if you take x and add it to 50 minus x, the x's cancel out, you're just left with 50. So x plus 50 minus x is 50. So those are my two numbers that are going to add up to give me 50. Now, I need the product to be a maximum. So I want to know my product is x times 50 minus x. So my product is 50x minus x squared, writing that in terms of descending order, it's negative x squared plus 50x. Now, at this point, if it's a parabola, which this is, the maximum or the minimum point is going to occur at the vertex. So we want to know, where is this vertex? Well, again, we go to the negative b over 2a, a being negative 1, so 2 times negative 1, and that would be positive 25. So the x-coordinate of my vertex is 25. Now, what's the other term? Well, it's 50 minus 25, which is 25. So my two numbers that have that maximum product would be 25 and 25. Now, how do we know that this is a maximum product and not a minimum product? Because an extrema exists at the vertex. So that means it could either be a maximum or a minimum. But in this case, we know that it's a maximum because this parabola has a negative leading coefficient, then that means that this parabola opens upside down. And because it opens upside down, then that vertex is a maximum. And that product we can either get as 25 times 25 because we know the two numbers and it's 625. Or we could get that answer by plugging in here. So we have the negative of our x value being 25, so the negative of 25 squared plus 50 times 25. Okay, so this would be negative 625, sorry. And then 50 times 25 is 1250. So 1250 minus 625 is 625. So we can either get the product by knowing what x and y are and multiplying them together, or we can get the product by plugging that x value that we found into the original equation. And it works either way there. So this is an application of using parabolas to come up with maximum or minimum products. In this lesson, though, remember, graphing quadratic functions with equations in standard form, the graphing quadratic functions in equation form needs to be in ax squared plus bx plus c form in order to get the vertex out as negative b over 2a. And you could also, if you wanted to figure out the vertex of the parabola, you could also use completing the square there to come up with it and get it in the form of f of x equals x minus h squared plus k. If you did that, this would be the x-coordinate of the vertex. This would be the y-coordinate of the vertex, the negative of h. So anyway, that's where we would go with that. Bye.